data visualization, data analytics, what is Tableau, why should we go for Tableau, how Tableau is being different from other BI products. We also saw about Tableau products and the Tableau architecture. I also explained you about the Tableau interface. Just we started. I gave you a hint how to download and install Tableau, whether you go for a desktop or a Tableau public. Let's explore more about the Tableau workspace and interface in today's session. So the Tableau workspace, it consists of menus, toolbar, data pane, cards and shelves, as well as you can create more sheets, dashboards and stories. The entire thing is called as Tableau workbooks. Worksheets that contain shelves and cards where you can drag and drop the corresponding data fields in order to build your views. So what you are seeing in the image is a Tableau workspace. So as soon as you connect to a data source, so you would be able to go for the sheet one where you would be able to see the data source connected, corresponding dimensions, measures. So you have two panes here, data pane, analytics pane. Data pane, you see the data which you have connected and the corresponding dimensions and measures, as well as the cards and shelves where you drag and drop your fields to create your views. So you have an explanation about the image in the next slide. Let's go for a live demo and explore all these options. I have Tableau Desktop, the latest version 10.5. So you can either download Tableau Desktop 10.5 or Tableau Public. So I'm going to use mostly the sample superstore data set. So that is going to be the data set which we are going to connect for the basic concepts. Later on we may use some other data sets. In that cases I will explain those data sets as well. As of now, let me explain you about the sample superstore dataset. Sample superstore dataset, it is a clean dataset. It is a saved dataset. It's provided by Tableau, where you have a clean data uh, as like Tableau can understand. So you have three sheets which has order information, written information, as well as the people information. So we are going to use this dataset to learn how to connect with Excel, as well as to learn about the interface and create your first visualization. So let me go back to Tableau interface. So on the left you see all the types of data sources. So if you check for the flat files, we have MS Excel, text file, JSON file, Microsoft Access, PDF file, spatial file, statistical files. More is for connecting with Tableau TDE files, data extract files. From the server, you have the various types of relational, dimensional, cloud data sources. Also, you have SAP data sources, Hadoop data sources, web data connected to pull the data from web sources. You also have ODBC connection. And these are the two data sources, saved data sources, sample superstore and world indicator. On the right, you have some training related stuffs to learn Tableau from online sources, and also daily they would be providing some visualization as visualization for the week. You also have some blog information about the recent updates of Tableau. And these are the recently opened files, and these are the sample workbooks. So let's connect to the sample superstore dataset. Click on the Microsoft Excel. Locate the folder where you have the saved data source. So I'm just going for Tableau data source file and locate the sample superstore file and give open. As soon as you connect to any data sources, either it is a flat file or relational databases, you would be seeing the corresponding tables or databases which from the corresponding data source. So as we already saw, sample superstore has three sheets: orders, people and returns. So let me consider these three things as a three tables. So first let me drag the order table. As soon as I drag the order table, you could see the corresponding columns which belongs to the order table, like row ID, order ID, and each column is also referred by the corresponding data types. In case if I need my second table also, let me pull the second table. So when you are going to pull your second table, there should be some relationship exists between these two tables where we are going to join these two tables based on that particular column. If you see here, region is a common column which is connecting the order table and the people table. Tableau supports 4 types of joins. So joining table is a way of combining information from multiple tables based on a field they share. So in this example, region is the column that is shared between two tables. So using region, we are going to join these two tables. So there are 4 types of join: inner join, right outer join, left outer join, and full join. So when you go for an inner join, it includes all the values, that is the matching records from both the tables. Left outer join, all the values from the left table and matching records from the right. Right outer join, all the values from the right table and matching records from the left. If you go for a full outer join, it takes record from both the tables irrespective of the matching values. Mostly we avoid full outer join in order to avoid the duplicates. So based on the requirement, you choose any of these 4 types of join and the corresponding columns which is common between these two tables, and you create a join relationship in order to join these two tables. Let me also pull the written table where it is joined with order table using order ID. Now we have connected to the data source, we have also pulled the required table. So as I said, you are seeing the columns corresponding to each table and each column is represented by a data type. Numerical values are represented by a data type, numerical or decimal represented by hash symbol. Attributes are string values denoted by ABC, and this is this date symbol. If you have a time, then you will have a small clock symbol using a date and time. We also have geographical fields which is denoted by a geographical symbol. So when you have fields such as country, city, state, those fields should be mapped with the corresponding geographical roles in order to make it as a geographical field. So as I explained you in the first session itself, we have 2 modes of connection: live connection and extract connection. Live connection, you're connecting to your data live. So live is nothing but a real-time extract. But when you want to consider the performance also based on the large data sets, we have to go for the extract connection, that is in memory. So it presents a fast in-memory data engine to optimize for analytics. You can connect to your data and after that with one click extract your data and get into your in-memory in Tableau. So you're going to either take the entire data set or the snapshot of data which is actually required for your reporting. Tableau data extracts the TDE file. So in 10.5 it has been converted as a hyper. Hyper technology really creates a very faster extracts even when you connect to a huge millions of records. Hyper is something which helps you to improve your performances tremendously compared to other BI tools in the market. Tableau data extracts are snapshot of data optimized for aggregation and loaded into the system memory to be quickly recalled for visualization. Extract tends to be much faster than the live connection because you're keeping your data in your local RAM. Especially when you have a complex visualization with large data sets, filters and calculations, it's definitely recommended as a best practices. You have to go for an extract connection. When you go for a live connection, it offers the convenience of real-time updates with any changes in the data source reflected in Tableau automatically. But live connections depends upon the speed of your databases, how the database is performing the query performances. Unlike extract, databases are not always optimized for faster performances, but extracts are always optimized for faster performances. With live connection, your data queries are only as fast as your database. So that's why, as a best practice, we always go for an extract connection. Even when you go for an extract connection, based on the data changes, you would be able to automatically update your extracts. So either you go for a live or an extract connection. When you click on the extract, you also have a filter section. In case if I have 10 years of data, but I actually require the current year or last 3 years or 2 years of data for my reporting, then I don't connect with 10 years of data. I filter out for the current year and I take only the required data, snapshot of data, and I'm going to keep it on my local memory. For this sample superstore, I have this 4 years of data. If I need only data for 2015, I create a filter only for 2015. So once you create your extract gets loaded into the local RAM file. That is, when you install Tableau in your machines, if you go to the documents folder, you would be seeing a folder called My Tableau repository. So your extract get automatically saved in this folder. As I said, in 10.5, Tableau data extracts saved with the extension .hyper. Previously, we had a TDE extension, Tableau Data Extracts. Both works on Fast Data Engine connectors. So since this is a flat file, in Tableau Public, you don't have these two modes of connection because Tableau Public supports only the flat files and it is also built in cloud, so you can only go by the live connection. You don't have option for extract because it is not used for real-time scenarios. As of now, I remove this filter since I need the entire data set and I go by live connection. Let me click on the first sheet 1. When you connect to any data sources, Tableau will assign each field either to the dimension or the measure section. Dimensions are categorical data such as names, dates or geographical data, so it would be assigned as a dimensional area. Any string values would be classified as dimension. The corresponding fact values which contain numbers are assigned as a measure section. So when you connect to any data sources, Tableau automatically separates the dimensions and measure section. So you could see here we have dimensions which are categorical values, date fields, ID columns, and the corresponding numerical fact values classified as measure section. Tableau automatically classifies the dimensions and measures based on some keywords like categorical values, ID columns, date columns, or numerical figures. If you find any of the dimension is being wrongly placed as a measure or a measure is wrongly placed as a dimension, you can easily convert a dimension to a measure or measure to a dimension. So once you have connected with the data set, you would be able to drag the corresponding data fields into the rows or a column shelf or a filters, marks card section or a page shelf in order to build your views. So let's create our first visualization. So I'm going to pull the customer names to the columns and sales to the rows, which gives me a bar graph, shows the sales across each customer. So as I said, in a very less time, it is going to give you the visualization based on the data fields you choose. Like dimensions and measures, we also have some field types called as continuous and discrete. By default, dimensions are discrete and measures are continuous. But in fact, all four combinations are possible. That is, you can also have discrete dimensions and continuous dimensions. Possibly when you have a date column. A date can be both discrete and continuous. So when I drag a customer name, it is in blue color. Blue color indicates it is a discrete field. And when I drag a measure, it is in green color. Green color indicates it is continuous. Discrete is something which is definable. Continuous is something which is not definable. Continuous is something which goes till infinite. Those types of values are classified as continuous. So now I have tracked the corresponding dimensions and measures into the rows and column sections, and we have created the first visualization. So once you have connected to a data source, you have created your visualization. Next thing, you have to save your workbook. Once you have saved your workbook, you would be publishing into a Tableau server or Tableau online, and only from there it is shared to the end users or customers. Tableau also has different file types. .twb. When you are going to save your workbooks with the extension TWB, it holds only the worksheets, dashboards and stories, but not the data. When you are going to save the same workbook with TWBX, it is an archive that contains a workbook along with all data sources as well as the external files. TBM stands for Tableau bookmarks that contain a single sheet. And TDE extracts the local copy of subset or entire data source to share and improve the performances. Now TDE is replaced by Hyper from 10.5. 10.5 is the latest release that is being released at mid of January 2018. TDS, shortcut to oftenly use your data source file with the extension is TDS, Tableau data source file. We also have package data source file with the external related files with extension .tdsx. So either you can save it with .twb format or .twbx. As I said, when you save it with .twb, it is not going to contain your data. It just contains the layouts, the sheets, dashboards and stories. But when we save it with .twbx, it is like a packaged archive which is also going to exclude the extract of the data sources which is being included as part of your workbook. So we always prefer to save the file with .twbx because even when you save it with twbx, you can share it with your other people without the data source because the required data is already attached as the extract data source when you save it as TWBX. TWB file alone is not enough to perform any analysis because it contains Tableau instructions for interacting with data source. But TWBX is a Tableau package file like our zip file which is going to contain all the necessary informations which is being used for creating that particular workbook. TWB files are XML files specially tailored to interact with data source. They are custom built to make IFSM visualizations that Tableau generates. Primary advantage of using TWBX file is that analysis can be performed without network or internet connection to your data because your data is already present on your computer as a packaged file. Let me also explain you how to do data preparation with text and Excel files. When you connect to any data sources, that is your flat files like Excel, sometimes the data may not be that clean. That is, you will be having lot of null values and also your header may not be proper. In that cases, Tableau may not be able to recognize the data file correctly. For that, Tableau itself has a feature called Data Interpreter which will automatically clean up your Excel files and make it as like Tableau understands. We also have pivoting and unpivoting your data based on the requirements. When you check a sample Superstore file, it is very clean and it is like how Tableau can understand. So when I show this Excel file, if you see, we have a header as our first row. So we have the corresponding column names in the third row and also we have some kind of null values. So when I connect this data source, connect to data, click on the Excel and locate the corresponding file and give open. Let me pull the data. You could see the column names are not properly identified. As I said, Tableau will take the first row as a column header. Since in the first row we have the title, Tableau could not predict what is it. So it automatically assigns some automatic column names for each column. In order to clean these types of Excel files, you can use the feature called Data Interpreter. When I check this box, use Data Interpreter, it automatically cleans the workbook and make it like how Tableau can understand. You can also review the results to know how Tableau is being using this Data Interpreter to clean the Excels. So it is applying various color coding. According to the color coding, it is interpreting the corresponding Excel and make it as like Tableau can interpret it correctly. So you also have a metadata field to check the metadata information of each column. You can sort your data either in ascending or descending per table or in the general basis. So if you see this data source, we have the various years as corresponding rows, corresponding columns. So as I said, Tableau also supports pivoting and unpivoting. So I can just click on the corresponding years and go for pivot values. So now the columns are changed into rows. So I can rename it as year. So now based on this my requirement, I can either go for pivoting or unpivoting. You also have option to split or do a custom split based on the data. So you can go for a split using the separator or you can go for the custom split. You can also create aliases for your data feeds. So these are the data preparation steps when you connect with the CSV or Excel files, how you can make your data available as per your business needs. In this session, I have explained you about Tableau interface, how to connect to an Excel data source. We also see about Tableau connecting to Superstore dataset, how to pull the corresponding tables, the joins, about live and extract connection. We also created our first visualization. We also learned some steps related to data preparation. Thanks for listening. Thank you.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with IntelliPat.